Equilibrium. The term equilibrium has often to be used in economic analysis. In fact, modern economics is sometimes called equilibrium analysis. Equilibrium means a state of balance. When forces acting in opposite directions are exactly equal, the object on which they are acting is said to be in a state of equilibrium. Types of equilibrium. Basically, there are three types of any equilibrium. 1. Stable equilibrium. There is stable equilibrium when the object concerned, after having been disturbed, tends to resume its original position. Thus, in the case of a stable equilibrium, there is a tendency for the object to revert to the old position. 2. Unstable equilibrium. On the other hand, the equilibrium is unstable when a slight disturbance evokes further disturbance, so that the original position is never restored. In this case, there is a tendency for the object to assume newer and newer positions once there is departure from the original position. 3. Neutral equilibrium. It is neutral equilibrium when the disturbing forces neither bring it back to the original position nor do they drive it further away from it. It rests where it has been moved. Thus, in the case of a neutral equilibrium, the object assumes once for all a new position after the original position is disturbed. When the word equilibrium is used to qualify the term value, then according to Professor Schumpeter, a stable equilibrium value is an equilibrium value that, if changed by a small amount, calls into action forces that will tend to reproduce the old value. A neutral equilibrium value is an equilibrium value that does not know any such forces, and an unstable equilibrium value is an equilibrium value, change in which calls forth forces which tend to move the system farther and farther away from the equilibrium value. In the following figure 2, the stable equilibrium is shown. When in equilibrium at point P, the producer produces an output OM and maximizes his profits. In case the producer increases his output to OM2 or decreases it to OM1, the size of profits is reduced. This automatically brings in forces that tend to establish equilibrium again at P. Figure 3 represents the case of unstable equilibrium. Initially the producer is in equilibrium at point P, where MR equals MC and he is maximizing his profits. If now he increases his output to OM1, he would be in equilibrium output at point P1, where he will obtain higher profits, because, at this output, marginal revenue is greater than marginal cost. Thus there is no tendency to return to the original position at P. Figure 4 represents the situation of neutral equilibrium. In this case, MR equals MC at all levels of output so that the producer has no tendency to return to the old position, and every time a new equilibrium point is obtained, which is as good as the initial one. Other forms of equilibrium. A short-term and long-term equilibrium. Equilibrium may be short-term equilibrium or long-term equilibrium, as in case of short-term and long-term value. In the short-term equilibrium, supply is adjusted to change in demand with the existing equipment or means of production, there being no time available to increase or decrease the factors of production. However, in case of long-term equilibrium, there is ample time to change even the equipment or the factors of production themselves, and a new factory can be erected or new machinery can be installed. B. Partial equilibrium. Partial equilibrium analysis is the analysis of an equilibrium position for a sector of the economy, or for one or several partial groups of the economic unit corresponding to a particular set of data. This analysis excludes certain variables and relationship from the totality and studies only a few selected variables at a time. In other words, this method considers the changes in one or two variables keeping all others constant, that is, ceteris paribus, others remaining the same. The ceteris paribus is the crux of partial equilibrium analysis. The equilibrium of a single consumer, a single producer, A single firm and a single industry are examples of partial equilibrium analysis. Marshall's theory of value is a case of partial equilibrium analysis. If the Marshallian method, that is, partial equilibrium analysis, is to be effective, even in its own terms, when applied to a hypothetical and idealized market, it's necessary that the market should be small enough so that its interdependence with the rest of the hypothetical economy could be neglected without much loss of accuracy. 1. Consumers' equilibrium. With the application of partial equilibrium analysis, consumers' equilibrium is indicated when he is getting maximum aggregate satisfaction from a given expenditure and in a given set of conditions relating to price and supply of the commodity. 2. Producer's equilibrium. A producer is in equilibrium when he is able to maximize his aggregate net profit in the economic conditions in which he is working. 3. Firm's equilibrium. A firm is said to be in long-run equilibrium when it has attained the optimum size when is ideal from the viewpoint of profit and utilization of resources at its disposal. 4. Industry's equilibrium. Equilibrium of an industry shows that there is no incentive for new firms to enter it or for the existing firms to leave it. This will happen when the marginal firm in the industry is making only normal profit, neither more nor less. In all these cases, those who have incentive to change it have no opportunity, and those who have the opportunity have no incentive. See General Equilibrium Analysis, Leon Walras 1834–1910, a neoclassical economist, in his book Elements of Pure Economics, created his theoretical and mathematical model of general equilibrium as a means of integrating both the effects of demand and supply-side forces in the whole economy. Walras' Elements of Pure Economics provides a succession of models, each taking into account more aspects of a real economy. General equilibrium theory is a branch of theoretical microeconomics. The partial equilibrium analysis studies the relationship between only selected few variables, keeping others unchanged. Whereas the general equilibrium analysis enables us to study the behavior of economic variables taking full account of the interaction between those variables and the rest of the economy. In partial equilibrium analysis, the determination of the price of a good is simplified by just looking at the price of one good, and assuming that the prices of all other goods remain constant. General equilibrium is different from the aggregate or macroeconomic equilibrium. General equilibrium tries to give an understanding of the whole economy using a bottom-top approach, starting with individual markets and agents. Whereas, the macroeconomic equilibrium analysis utilizes top-bottom approach, where the analysis starts with larger aggregates. In macroeconomic equilibrium models, like Keynesian type, the entire system is described by relatively few, appropriately defined aggregates and functional relationships connecting aggregate variables such as total consumption expenditure, total investment, total employment, aggregate output and the like. In macroeconomic analysis, many important variables and relationships tend to be disappeared in the process of aggregation. There are two major theorems presented by Kenneth Arrow and Gerard Debreu in the framework of general equilibrium. 1. The first fundamental theorem is that every market equilibrium is peri-to-optimal under certain conditions, and 2. The second fundamental theorem is that every peri-to-optimum is supported by a price system, again under certain conditions. Uses of general equilibrium. 1. To get an overall picture of the economy and study the problems involving the economy as a whole or even large segments or sectors of it. 2. It shows that the quantities of demanded goods or factors are equal to the quantities supplied. Such a condition implies that there is a full employment of resources. 3. It also provides with an ideal datum of economic efficiency. It brings out the fact that long-run competitive equilibrium is a standard of efficiency for the entire economy. Only when the competitive economy obtains general equilibrium shall its economic efficiency be at its peak, and there shall be no further gains made by any reallocation of resources. 4. General equilibrium also represents the state of optimum production of all commodities, because there can be no overproduction or underproduction under such conditions. 5. It also provides an insight into the way the multitudes of individual decisions are integrated by the working of the price mechanism. It, therefore, solves the fundamental problems of a free market economy, viz. What to produce, how to produce, how much to produce, etc. This analysis shows that such decisions with regard to innumerable consumers and producers are coordinated by the price mechanism. 6. The general equilibrium analysis also gives us a clue for predicting the consequences of an economic event. 7. It also helps in the field of public policy. The formulation of a logically consistent public policy requires a complete understanding of the various sector markets and aspects of individual decision-making units, and the impact of policy on the whole economy. Limitations of general equilibrium analysis. 1. The Walrasian general equilibrium system is essentially static. It treats the coefficient of production as fixed. It considers the supply of resources to be given and consistent. It also takes tastes and preferences of the society as fixed. 2. It ignores leads and lags, for it considers everything to happen instantaneously. It is supposed to work just in the same way as an electric circuit does. In the real world, all economic events have links with the past and the future. 3. Walrasian general equilibrium analysis is of little practical utility. It involves astronomical volumes of calculations for estimating the various quantities and practices. This makes its application practically impossible. Even the use of computers cannot be of much help, because such a system cannot aid in collecting and recording the innumerable sets of prices and quantities that are required to formulate these equations. The critics further argue that even if such a solution exists, the price mechanism may not necessarily cover it. 4. Last but not least, the general equilibrium analysis falls to the ground as its star assumption of perfect competition is contrary to the actual conditions prevailing in the real world. General disequilibrium. Keynesian theory. Neoclassical economics thinks in terms of a market system in which supply equals demand in every market, so that no unemployment could ever occur. But this is an assumption. Keynes suggests a market system in which disequilibrium can occur in some markets, including labor market, and in which the disequilibrium can spread contagiously from one market to another. Keynes' idea was that, when this spreading disequilibrium settles down, there would be a kind of equilibrium, not supply and demand equilibrium, but often termed as general disequilibrium. Take an example of a commodity, say cellular telephone sets. Its equilibrium of demand and supply is shown in the following figure. In the above figure, M.Sc curve is the marginal cost curve for the commodity. Originally, the market is in equilibrium at price P1 with demand curve D1. Then, for any reason, demand for that commodity decreases to D2. Neoclassical economists tells us that the new equilibrium will be at price P3. But, in fact, the prices do not drop quite that far. Instead, prices drop to P2. Perhaps this is because the businessmen do not know just how far they need to cut their prices, and are cautious to avoid cutting too much. At the price P2, the seller can sell only QD amount of output. By producing QD amount of output at price P2, the producers are not maximizing their short-run profit. We have disequilibrium in the sense that production is not on the marginal cost curve. At P2, the sellers can sell QD amount of output, but they cannot produce the same amount of output. Here is a qualification. Producer might temporarily produce more than QD, in order to build up their inventories. but there is a limit to how much inventories they want, so they will cut their production back to QD eventually. With a reduction of demand for cellular phones, any economist would expect a reduction in the quantity of that commodity produced. Neoclassical economics leads us to expect that the price would drop to P3 and output cut back to QE. At the same time, a certain number of workers would be laid off and would switch their efforts into their second-best alternatives, working in other industries, perhaps at somewhat lower wages. But the disequilibrium model states that the production and layoffs would go even further, with output dropping to QT. A reduction in income does not only reduce the demand for cellular phones, but it also reduces the demand for all other normal goods as well. This disequilibrium will spread contagiously through many different goods markets, through the effect of disequilibrium on income. So every other industry will face a reduction in demand because of the reductions in productions in many other industries.